Hi, so we're going to have a quick look at sum and products of roots. This is something which is, in some ways, is actually a really simple concept, but can produce some really nice problems. Okay, and in the course, the Math HL course you've been studying with Pamoja, lots of those problems are the type where you're asked to find new equations from the roots or understand relationships and so on. We're going to look at a couple of more kind of almost, let's say practical problems, but more applied efforts. But first of all, let's remind ourselves about some products of roots. So imagine we've got a quadratic equation, ax squared plus bx plus c equal to 0. And this equation has two roots. Okay, we'll call them alpha and beta. In other words, if we put alpha or beta into this equation, we get a 0. And the thing about this is that when we consider solving an equation, alpha and beta are such that we can always rewrite it like this, because if we put alpha into this, it will equal 0. If we put beta into this, it will equal 0. So these are actually equivalent forms. If I multiply out my equation, I'll get this plus alpha beta. There is a difference, of course. If I look at this equation, it's got an a, but I can deal with that because, of course, I can always divide through the equation by a without changing anything because it's equal to 0. So what we're saying here is that these two equations are exactly the same. Okay, they have exactly the same properties. Now, next thing to do is to compare them. Well, when we do the comparison, what we see is that the alpha plus beta, the sum of the roots, so if we add the two roots of a quadratic together, we'll get negative the two coefficients a and b divided. And if we multiply the two roots, alpha beta, we'll get the two coefficients c and a divided. Now in the HL Pamoja course, you'll have seen quite a few questions asking, well, okay, what happens with 1 over alpha plus 1 over beta? Okay, and we do clever things with it. We can ask questions about this, and we find that we can get new expressions for these, which allow us to write new quadratic equations. So if you look in the course, you'll see examples of those. The type of problem I want to look at right now is this. Quadratic equation given with k's, here are my coefficients a, b and c, and has one root which is 2 more than the other. Find k and the two roots. Well, the first thing to note is that we can say that alpha and beta are actually going to be alpha and alpha plus 2, because one root is 2 more than the other. Okay, in this case, beta, alpha plus 2, is 2 more than alpha. Now let's look at this equation. So let's just get it in the form. Oh, no, let's not worry about that. Okay, so first of all, let's think about a, b, and c. So in the quadratic, a equals k, b equals k minus 8, and c equals 1 minus k. C. And that means that we can start talking about sum and products of roots. Well, first of all, the sum, alpha plus 2 will equal minus b over 8. So minus k minus 8 over a. And the product, alpha times alpha plus 2, will equal c over a. Well, first of all, I think what we can get here, we can get an expression for alpha, because what we've got, of course, is that alpha, well, 2 alpha plus 2 equals and I will take the negative through, and I'll get 8 minus k over k. So 2 alpha will equal 8 minus k over k minus 2, which equals 8 minus k minus 2k over k, which equals, I'll put it into here, 8 minus 3k over k. And from this, of course, we can get value for alpha, which will be 8 minus 3k over 2k. Okay, we're going to go back up to what we had. Now, here we had alpha times alpha plus 2. So a little think about what that looks like. And it's going to get a little bit messy, but we can deal with that. So we're going to get alpha, 8 minus 3k over 2k, times alpha plus 2, 8 minus 3k over 2k plus 2, equals 1 minus k over k. 1 minus k over k. So what have we got here? So we've got 8 minus 3k over 2k times 8 minus, I'm going to get minus 3k plus k, so it's 8 plus k over 2k equals 1 minus k over k. First thing is, we'll have a k cancelling here, so we can lose that. Right? And I've got 2k times 2, so I get 4k minus 4k squared here. And here I'm going to get rather exciting thing of 64, as I multiply these two top lines, plus 8k minus 3/8k, which could be minus 16k, 8k minus 24k, minus 3k squared. And I think I'm going to take everything over. The minus 4k squared become a plus 4k squared. Minus 3k squared is k squared. Minus 16k minus 4k is minus 20k. And then I'll get plus 64, which equals 0. Okay, so if I think about this, I've got to factorize k minus, how about minus 16 and k minus 4, I think will work. Okay, look at that one, that should work. And will give me two answers of k equal to 4 and k equal to 16. Now what I can do, I'm not going to do this now because I'm sure you can do this for yourself. I can go back here and I could work out, sorry, let's get that, and I could work out what alpha is and what beta is, because alpha is 8 minus 3k over k, so 8 minus 3k over 2k, so alpha over here, so we'd get alpha will be 8 minus 24 over 2 times 4 is 8, which I believe will be negative 2. So we get negative 2 and 0 will be 2 of the roots. Remember the other root is alpha plus 2. Okay, it's negative 2, so 8 minus 1 over 2k. And the other one would be 8 minus 16 times 3, which is 64 over 32, which will be 8 minus 32, which will be a slightly different number, is going to be a quarter minus 2, which will be minus 7 over 4. and then the other alpha will be plus 2 will be 1 over 4. So as we go through this, we can see how we can get those answers. So that's quite what I want to go back to is the key to this is the algebra is a little bit of a mess, and in theory, if you had a calculator with you and you were allowed to use it, there's a paper 2 exam, you could solve this with your calculator. But the key point is, looking at the problem, one root is 2 more than the other, alpha and alpha plus 2 are my 2 roots. And I can relate the sum of those roots and the product of those roots to the division of the coefficients using what we know about sum and product of roots. Okay, so let's look at a slightly different problem. Okay, so this equation, it's such that the sum of its roots is twice their product. Okay, so first of all, the sum of the roots, of course, is minus, well, let's first write A, B, and C. So A is minus, sorry, I've done that wrong. So B is minus 1 plus K. A equals K, and C equals 3K plus 2. Sorry about the K there, it's really ugly. That's better. So first of all, minus B over A, of course, which is the sum of the roots, alpha plus beta, basically I'm just applying a formula here, is minus B over A is 1 plus K over K. And the product of the roots is going to be 3k plus 2 over k. What we're told is that the sum of its roots is twice alpha plus beta equals twice the product. So in other words, 1 plus k over k equals twice 3k plus 2 over k. K's cancel, and I get 1 plus k equals 6k plus 4, which gives me that 5k equals minus 3, k equals negative 3 over 5. Okay, so I've got my k value. The question now is what are the roots? Different things I could do here. And in fact, what I'm going to do is I'm going to look at this. I'm just going to put it back into the original equation. So just so we're on the same page, I'm going to just substitute in. So I've got minus 3x squared over 5 minus 1 minus 3 over 5x plus minus 3 times minus 3 over 5, which is minus 9 over 5 plus 2 equals 0. So that gives me minus 3x squared over 5 minus. Now 5 over 5 minus 3 over 5 is minus 2 over 5, or is plus 2 over 5, it's subtracting, so minus 2 over 5x. And then minus 9 plus 2 times 5 is plus 1, so I get plus 1 over 5, which equals 0. Of course, the 5's will all cancel, and I'm going to get minus 3x squared minus 2x, it looks like a smiley, not a minus, doesn't matter, plus 1 equals 0. Just go back to show I'm not cheating. There we go. So I'm just dividing everything by 5, minus 3x squared minus 2x plus 1. And this I'll rewrite as positive coefficient x squared, makes life a wee bit easier. Minus 1, and I'm not very happy with how that turned out. Doesn't matter. We'll write that again, because it's just ugly. So 3 plus 3x squared plus 2x minus 1 equals 0. Factorize 3x and x. We're going to have 1 and 1, and I'm going to put a plus here. I'll give you my plus 3x, and minus here. We'll be subtracting the x, give me plus 2x, and that will lead to x equals 1/3 and x equals minus 1. Okay, and there's my solution. So I've got k, and I've got the 2 roots.